I am Leena Khatia. Today I'll be giving a presentation on interrupt IO and concurrent IO. So starting with interrupt IO, interrupt-driven IO is an alternative scheme dealing with IO. Interrupt input-output is a way of controlling input-output activity whereby a peripheral or terminal that needs to make or receive a data transfer sends a signal. This will cause a program interrupt to be set. For input, the device interrupts the CPU when new data has arrived and is ready to be retrieved by the system processor. For output, the device delivers an interrupt either when it is ready to accept new data or to acknowledge a successful data transfer. Simple interrupt processing happens like this. Device controller or other system hardware issues an interrupt, then the processor finishes execution of the current instruction, then the processor signals acknowledgement of interrupt, and then processor pushes PSW and PC onto control stack, then the processor loads new PC value based on interrupt. Then in the software part, it saves remainder of process state information, then process gets interrupt, then restore process state information occurs, then restore old PSW and PC. Basic operation of interrupt is CPU issues read commands, IO module gets data from peripheral while CPU does other work, I/O module interrupts CPU, CPU requests data, I/O module transfers data. Interrupt processing: a device driver initiates an interrupt an input-output request on behalf of a process. The device driver signals the input-output controller for the proper device, which initiates the requested I/O. The device signals the I/O controller that is ready to retrieve input, the output is complete, or that an error has been generated. The CPU receives the interrupt signal on the interrupt request line and transfer control over the interrupt handler routine. The interrupt handler determines the cause of the interrupt, performs the necessary processing, and executes a return form interrupt instruction. The CPU returns to the execution state prior to the interrupt being signaled. The CPU continues processing until the cycle begins again. Advantages of interrupt IO is it is fast and efficient. Disadvantages are it can be tricky to write if using a low-level language. It can be tough to get various pieces to work well together, or usually done by the hardware manufacturer and OS makers like Microsoft. Now, on concurrent IO. Concurrency is the execution of the multiple instruction sequences at the same time. It happens in the operating system when there are several process sets running in parallel. The running processes threads always communicate with each other or through shared memory or message passing. Concurrency results in sharing of resources, results in problems like deadlocks and resource starvation. Principles of concurrency are both interleaved and overlapped processes can be viewed as examples of concurrent processes. They both present the same problems. The relative speed of execution cannot be predicted. It depends on the following: the activities of other processes, the way operating system handles interrupts, the scheduling policies of the operating system. Problems in concurrencies are sharing global resources, optimal allocation of resources, locating programming errors, locking the channel. Advantages are running of multiple applications at the same time, better resource utilization. It enables the resources that are unused by one application can be used for another applications. Better average response time. Without concurrency, each application has to be run to completion before the next one can run. Better performance. It enables the better performance by the operating system. Drawbacks are it is required to protect multiple applications from one another. It is required to coordinate multiple applications through additional mechanisms. Additional performance overheads and complexities in operating systems are required for switching among applications. Sometimes running too many applications concurrently leads to severely degraded performance. Issues of concurrencies are it's non-atomic. Operations that are non-atomic but interruptible by multiple processes can cause problems. Race conditions. A race condition occurs of the outcome depends on which of say several processes gets to a point first. Blocking. Processes can block waiting for resources. A process could be blocked for a long period of time waiting for input from a terminal. If the process is required to periodically update some data, this would be very undesirable. Starvation. It occurs when a process does not obtain service to progress. Next is deadlock. It occurs when two processes are blocked and hence neither can proceed to the execution. Here are some reference links which I used to make this PPT, and I've created this presentation in the guidance of Anita Mahajan ma'am. Thank you.